In this presentation, we are going to see the parallel input, serial output, and parallel input, parallel output shift register, that is nothing but PIPO and PISO form. So we will start from the PISO, that is nothing but parallel input and serially output. So what we have here is a 4-bit register. A, B, C, D consists of 4 flip-flops, which are D flip-flops, because we are not going to change the data here, because we are going to shift the data parallelly input to serially output. And serial output will be taken out from the flip-flop D. So QD will be our serial output. So from QD we will have serial output. Now data is parallelly in. So first form what we have here is parallel input, serial output, PISO format. So data is parallelly in. So for very first clock pulse the data is parallelly in. So what we have here, let us consider that data is 1 0 1 1. So what we have here, DA is equal to 1, DB is equal to 0, DC is equal to 1, and DD is equal to 1. So before applying to this input to the respective flip-flops A, B, C, D, what we need to do, we need to clear the flip-flop. Okay, that's why we use here clear terminal. So all the clear terminals are shorted to give the reset pulse, and what we have here is the reset pulse, which is before applying the very first clock pulse we will apply reset pulse for very short duration. A 0 pulse will be given to it. So what we have here is data will be parallelly in. So all the flip-flops will be reset to 0 before applying the first clock pulse. So let us see the clock diagram. So clock diagram is here, and depending on this clock diagram we have 4 outputs. So that is nothing but, this is the line for A, B, C and D, and the final line will be for the output. So let me notify you here, this will be QA, QB, QC, QD line, and this final line will be for output, serial output. And let me drop down all the clock cycles, since we have used the negative edge triggered flip-flop here. So I am identifying the falling edges for the clock cycle to which the output is gonna change. So before applying the first clock pulse, what I will give here is the reset pulse. So for very short duration of time I will apply a 0 pulse here, that is nothing but a reset pulse. So all the flip-flops will be reset to 0. So what we have here is 0 0 0 0. The output will also be 0 because QD is the output. Okay, now for the first clock cycle what will happen, data is parallelly in, that is nothing but DA will be 1, DB will be 0, DC will be 1, DD will be 1, 1 0 1 1, that was the data. So the first bit is 1 here, DD. So for the very first clock cycle all the data will be fed into the registers A, B, C, D, consists of D flip-flop. So what we have here is 1 0 1 1. Still the output is gonna 0. Why? Because this 0 will be shifted to out, so output is 0. Now data is parallelly in. So what you can indicate here is, for this clock cycle first, it is data input and the output is 0. And from the second clock cycles onwards, so this is the clock cycle second, third, fourth and fifth. So what will happen from the second clock pulse, you cannot input the data since we have to take out this 4-bit data outside. So we have to wait for some time. Why? Because for the second clock pulse this 1 will be taken out and this 1 will shifted here, 0 will come here, 1 will come here, and suppose there is no data, so I am introducing a 0 here. So 1 will be taken out, so here 1 will be there. For the next cycle this 1 will be taken out and this data is shifted downwards, so this will be 0, this 1 will come here, the 0 will come here. Again I am adding 1 0 because suppose there are no data, so I am adding zeros. For the third clock cycle again 1 will be the output, and so on. For the fourth clock cycle there will be this 0 will be taken as output here, and for the fifth clock cycle this 1 will be coming here. you have to wait till the 5th clock cycle, because for the 5th clock cycle all the 4-bit data is taken serially out. So this is, you can call as serial out data. After the 5th clock cycle, for the very 6th clock cycle, what you can do here is again you can input the data. So once you have inputted the data in the clock cycle 1, you take till the 5th clock cycle to take all the data serially out, and then you're gonna move to the 6th clock cycle where you can introduce a new set of 4 bits to the shift register. So once again there is a disadvantage in parallel input serial output, that you have to wait for the number of clock cycles. Means number of bits are 4 here, so you have to wait 4 clock cycles, 1 2 3 4, to take the data outside. And for the next clock cycle you can introduce new set of inputs to the shift register, that is nothing but parallel input serial output.